Hey everyone, it's Miss Heineman. Happy Monday. It's Monday, March 23rd, and I thought I'd start us off with your homework from Friday, which was overall really good for those of you that were able to turn it in. Awesome. A quick reminder, any sort of homework that you missed last week, I'd love to see by the end of the day today on Monday, just like we did during the school year when we were in school together. So there were some mixed answers here for the last line on this question from the homework last Friday. And so I know you were given that you have these right angles here, angle ROM and angle ROP. And then you were given that these two sides were congruent. And many of you said RO is congruent to RO by reflexive property, which is awesome. And so when you filled this out, the last line, triangle RMO is congruent to RPO. That seemed to be no problem to make those triangles match, but the reason was mixed. And so if I were to draw out these triangles separately, like this, and let's just put the markings on here, like that, put even the letters here. I want you to see the difference between side angle side versus right angle hypotenuse leg and which one it really is. And if I look at this for side angle side, a big clue with this right angle here is that the angle for side angle side has to be between the two sides that were proven congruent. So if I look at the two sides that were proven congruent, if I would like to use side angle side, the angle has to be here. The angle has to be there, but that is not what I have. If I look, let me erase that real quick. If I look really at my picture, I have my right angle, which is great. And then I have a hypotenuse here. And then I actually have the leg, the reflexive side here. Okay, so the reason the triangles are congruent, I borrowed the shortcut RHL. So that's what I was looking for that one. If you put side angle side, just be careful. Sometimes it actually is side angle side, just the angle has to be between the two congruent sides. Okay, so now we're going to our lesson. Here we are on CPCTC. It's kind of funny. It's just a shortened version instead of writing stuff out. I can show that the corresponding parts of congruent triangles are congruent if and only if the triangles are congruent. It's a lot of words, but we'll get to that after we do our warm-up. And so I've got two congruent triangles, GRA, and I drew that really big, so maybe I will just write it over here, PES, and I'm going to label all my sides, and I want you to do the same on your paper. And then I would love for you to pause the video and then try it out, okay? So at this point, pause the video and try it out. And when you're ready, come back and look at my solution. All right, just give you a moment. Try that and then pause, okay? So now, welcome back. I'm assuming you paused. And so here's how I would do it. If these triangles are congruent, I know these are corresponding sides, these are corresponding sides, and these are corresponding sides. So I'll just start with the first set. 2x plus 3 is equal to 15, which means 2x equals 12, so x is 6. Awesome, because I want to find x plus y plus z. All right. Then for my y is 4y plus 2 equals 6y minus 8. If I move the 4y over, I get a 2y. If I move this 8 over, I get a 10. So y is 5. And then for my last set, 2x plus y equals z. So if I substitute 6 for x and 5 for y, that gives me z. So 12 plus 5 is 17. That's my z. So x plus y plus z equals 6 plus 5 plus 17, which is 28. So if you got 28, nice job. All right, so now here we go into our new lesson, okay? So we're gonna write a 2-column proof. This is a nice one to look at. Start with our givens, let's do some planning. This gives us angle 1 and angle 2 are right angles. Right, that's what it tells us. I'm gonna call these angles 1 and 2. It also means 1 and 2 are also congruent because they're right angles. And then E is the midpoint of segment BD. So in my picture, that means BE is congruent to ED. Okay? And I do need a third match somewhere. And so if I'm looking for a third match, remember I'm either looking for vertical angles or a reflexive side or angle. So an angle or side that they share. And I see one right here. So there's my third match. So if I look at these separately, I drew out one. And now if you remember what I said earlier, is this side angle side or our right angle hypotenuse leg? Look at where the angle is compared to the two sides. So the angle here is between the two sides, so I'm going to say side angle side, all right? And now we write our proof. So we'll just start, if I'm going to do side angle side, I'll start actually with my reflexive side first. CE is congruent to CE. Not given. Reflexive side. So reflexive property. All right. So there's a side. And if at this point you wanted to pause and try out the rest of the proof before you saw the rest of this, that would be great. Otherwise, just keep going with me. So now I'm going to get the angle. This is actually going to be a few steps because I do have this given, but then I have to use that given to tell me what angles are congruent. So angle 1 is congruent to angle 2 because if I have two segments that are perpendicular, that's what I was given, they create two congruent right angles. That's what happened. Okay, so there's my angle. And then I've got to put my other side, which is from my given as well. E is the midpoint of segment BD. Given. All right. Oops. And we'll get to that question at the bottom. Okay. So that means if that's the midpoint, oopsies, segment BE is congruent to segment ED. That's my other side. You can write a midpoint divides a segment into two congruent segments. And that's just a definition you learned at the beginning of the year, so nothing new there. And then you can see the two triangles are congruent. And we decided earlier that it was by side angle side. Side angle side. The first set of sides was at step 1. Second match was the angles at step 3. And last set of sides at 5. Okay? So that would be a level 1 proof. Can you prove a set of triangles congruent? There are 3 levels this unit, and so we're going to get into level 2s today. So if you preview here, after writing this proof, do you have enough information to prove that angle B is congruent to angle D, or segment CB is congruent to segment CD? And I want you to really think about that, because now at this point, after you've proven these triangles are congruent, by definition of congruent figures, okay, by definition of congruent figures, you can show any other set of corresponding sides or angles congruent. So yes, of course. The answer is going to be yes. All right? By CPCTC. So it just means if you have two triangles congruent, you can show any other corresponding sets of angles or sides congruent. That's pretty awesome. All right? We'll write this formally in our yellow pages in a moment, but let's just write it here so we have it and we can practice it a little bit. All right, so after writing this proof, do you have enough information to prove angle B is congruent to angle D, or segment CB is congruent to segment CD? Yes. And the reason would be this awesome reason. Corresponding, it's very long, parts of congruent triangles are congruent. So I'll show you where the CPCTC comes from. So if you want to memorize this, CPCTC, you can use that. Some people don't like memorizing that, and they like to say, well, if two triangles are congruent, then the corresponding sides are congruent, if they're talking about sides. Or they like writing, if two triangles are congruent, then the corresponding angles are congruent. It just depends. So if you're showing an extra set of sides, of course use this one. If you're showing an extra set of angles, use this one. Okay? And we'll write that in our yellow pages later, but at least now you have it. All right, we're gonna go practice. This is a level 2 proof. So going 1 step or 2 or 3 beyond, just showing the triangles are congruent. Okay? So here we're gonna mark it up as usual. There, S is the midpoint of segment AT, so that means these are congruent. And then we're going to look for reflexive sides or reflexive angles or vertical angles. We have no verticals, but we do have that reflexive side. So we've got our triangles by side, side, side. And that's always our goal, because even if you look here, it's not telling us which triangles to prove congruent, but your goal at this point is to try to prove triangles congruent first and then go from there. Okay, so we're going to do that. Segment WA is congruent to segment WT, given S is the midpoint of segment AT, given, and then what was true about that? We got two segments that are congruent, AS congruent to ST, because a midpoint divides a segment into two congruent segments. Okay? And then we had a reflexive side. So there's our side, side, side. WS is congruent to WS. Reflexive property. Okay? So now we just have to make sure we get our triangles right. Triangle, oh my gosh, I keep zooming in, sorry. Triangle WAS is congruent to triangle WTS by side, side, side steps 1, 3, and 4. So now our goal really again is to get angle 1 to congruent to angle 2. And we can do that by first proving these angles are congruent right here. Angle 3 and angle 4. Notice those angles 3 and angle 4 are inside the triangles that we just proved congruent. So we have to use that first. So you can either write CPCTC because you already proved the triangles congruent, or you could write if two triangles are congruent, the corresponding, let's look at these, they are angles, so the corresponding angles are congruent. Okay? And then, let's look at this. If angles 3 and 4 are congruent, why do you think angle 1 and 2 should be congruent? Well, they actually end up being supplementary to those angles. So we can say angle 1 is congruent to angle 2 because the supplementary angles, the subs of congruent angles, are always congruent. Right? If angle 3 and angle 4 are 30 degrees, that means 1 and 2 are 150. All right, nice job. We'll move on to the next.